Hi, I'm Ken Trimber. Welcome to the KTA University podcast. The podcasts are designed to tackle subjects relevant to construction, fabrication, cleaning, and painting, both commercial and industrial. Today's topic is measuring surface profile. We're going to discuss a couple different methods for measuring profile and some of the complications that might occur when using both on the same job. My guests today are Bill Corbett and John Todd. Bill, I understand you're going to be addressing the digital profile reading equipment, and John, you'll be doing the Replica Tape. Bill is very active in ASTM D146. They're the committee that develops the standards for measuring surface profile. And John is active in the NACE committees that develop their standard practices for profile. Before we begin, I just want to mention to those who are listening and not viewing this, there's going to be a lot of hands-on demonstration. Now, while both Bill and John will be discussing what they're doing and kind of walking through the steps verbally, it might help for you to eventually log on to KTAUniversity.com to actually look at the podcast to see the instruments in use. Now, before we begin, guys, to set the stage for those who are listening, if you can describe briefly how these instruments are used. Bill, I'd like to begin with you on the digital equipment.
Sure. The digital depth micrometers conform to ASTM D4417 method B. There's a method A, which is a visual comparator, there's a method B, which is a depth micrometer, and then method C is the replica tape. These particular devices or gauges conform to method B. We have the surface profile gauge, manufactured by DeFelsco Corporation, and then we have the Alcometer 224. Both gauges have a 60-degree cone-shaped point at the base of the instrument. The theory is that the base of the instrument would rest on the peaks of the profile, while the 60-degree cone-shaped point would protrude down into the valleys of the profile. So we'd simply power up the gauge. We want to verify zero using a float glass plate that is provided with the gauges. After we verify zero, we'd place the gauge on the prepared blast clean surface and take a series of measurements. And both gauges work similarly.
Now, Bill, I see that was reading in tenths of a mil. Is that common for both instruments?
Yes.
Tenths of a mil. And do they also read in microns?
They read in microns. You can set up the gauge to read in mils or microns ahead of time.
Okay, great. John, could you explain the replica tape?
Sure. The replica tape, in this case here, we have Testex Coarse, Testex Extra Coarse, and Extra Coarse Plus. And the three different types of tape signifies what range of profile that they can measure in. The coarse measures anywhere between 0.8 to 2.5 mils. The extra coarse goes from 1.5 to 4.5 mils, and then the extra coarse plus is above the 4.5 to about 5 mils. You want to make sure that you select the right type of tape based on the profile to make sure that there's enough compressible material there to fill in the gaps, but also not so much that it actually releases. So I can go into more detail on that later. You also need to have a rounded burnishing tool, and I can show you how this goes by sampling or using the extra coarse plus. You simply take the tape off, apply it to the surface, and then use the rounded end of the burnishing tool to press down on the tape itself. And what this is doing is this is compressing the compressible foam, but the compressible foam is protected by a 2 mil Mylar, which is non-compressible film on top of it. And I'm making sure that I press down on this to sufficiently compress the foam to get a replica of the profile underneath. Once I take this foam and the tape, I can take it with the spring micrometer. This one here, I want to make sure that it is reading 0 with the anvils closed. And I will take the reading on it in the center of the area, look at the reading, and then I would subtract 2 to deduct for the Mylar film. Now in this case, the reading would be 2.5 mils on the profile. So that would be acceptable in this range, and the reason I'm saying in the range here is because as I mentioned earlier, the coarse test text tape and the extra coarse have different ranges that they read in, and there is an overlap area between the two. The purpose of the overlap between the two is that the low end of the extra coarse is not as accurate, and the high end of the coarse would not be as accurate either. They're both very accurate in the middle of those ranges, but not on the tail ends. So you would in that case, you would take an extra coarse and a coarse reading, add them together, and divide by 2 to figure out your reading.
All right, John, let me ask you a couple questions there. You've mentioned some thickness ranges. How do you memorize that, or is it right on the tape?
Well, thankfully, the test text tape has the ranges, and they're color-coded to show the range. So the red and the purple here are the coarse, and then the blue and the purple is the extra coarse, and that overlap area is where you would need to take a reading from both the coarse and the extra coarse and average the two.
Okay, so if, going to that overlap area, if I'm using the coarse tape and I'm to the left side of the overlap, my reading is good as is.
That's correct.
And if I'm using the extra coarse, I'm to the right side of the overlap, that reading's good as is.
Correct.
No matter which tape I use, if it's in the overlap, I must take the other tape, take both readings, divide by 2 to get the reading.
That's correct. And the overlap would be between 1.5 and 2.5 mils.
Okay, now you mentioned 2 mils of Mylar that holds this emulsion together. I see on your micrometer, you set it to 0 and subtracted the 2 mils in your head. Is there another way to do that?
Absolutely. So before, when you set it, you could see where it's set to 0. You could actually turn the dial back 2 mils to 8. And what this would do is automatic. It is so you don't have to do the math yourself. It is subtracting the 2 mils for the Mylar, and then when you would take the reading, you'd still do the same. You'd open it, press the tape in the center of the anvil, release it, and whatever the reading is then, it would be your actual reading. So you don't have to do the deduction through math.
Okay. I see another micrometer in front of you. What is that?
So this is the linearizing gauge. The nice thing about this is that it's a smaller range. So the spring micrometer I was using here goes from 0 to 50 mils. The linear is a tighter range. It's more in line with what the surface profiles in the industry would see. The convenience of this gauge is that when you use it, it actually deducts the Mylar already. As long as you see here, there's a 0 point. Much like you would set the 0 here on the other micrometer, you would use this linearizing. It says 0. So you set so that the gauge is reading there, and then same thing, you would put the tape inside of the anvil in the center, and then release it, and it would show you the reading subtracting the Mylar. But it also, there's a area here in the red, so in this case I'm using extra coarse. If this reading were to be in the red, it would tell me I'm using the wrong type of test text tape, and to use the coarse. So this would, and also using this, you don't have to do that overlap area, because this shows you which film or which test text tapes you should be using.
Okay, I noticed those are spring micrometers. Is there a risk of crushing this profile and using that?
Well, when using the spring micrometers, there may be a very slight chance, but nothing to materially affect the readings. In fact, if it does compress it, it's more of a rogue point, and this is an overall average. So by using this this anvil, it's not as precise as the point used on the digital micrometer, but it gives you an overall average, and it seems to be more, I don't say accurate, but you're not taking as many readings. It's not as dependent on user deducing which ones to keep, which ones to not. So it would be more reflective of the average.
Okay, so crushing a few high peaks is not a problem necessarily.
That's correct.
Bill, when you're using the depth micrometer, how many readings do you take?
Well, actually, according to ASTM, you're supposed to take 10 readings per area. And I know that sounds like a lot of readings, but because it's digitized, you can probably take 10 readings in, 12 to 15 seconds or so.
So when I have 10 readings in a spot or in a location, What do I do with those readings? How do I record the results?
Well, currently, ASTM D4417 method B says to take the series of 10 readings and then report the maximum for that area. And then, of course, you would be checking multiple areas across the structure and then averaging the maximum values for all of those areas. The key is with this instrument is it takes pinpoint measurements, and you could have an unusually high peak or an unusually low valley, and it can find that. And the key is to be able to recognize that you have an outlier. For example, you might get a variety of readings between 2 and 3 mils, and all of a sudden you get one reading that's 6 mils that doesn't match any of the others. We would consider that an outlier. You would throw that out. So the point is you might have to take 12 readings to get 10 good readings that you would then report the maximum on.
So I report the maximum value of those 10.
That's
so if
correct.
I have 2, 2.5, 1, 3, my answer is 3.
That's correct.
Is there another way to do that?
The ASTM standard does allow, if contracting parties agree, to average the values that you get. So you would take 10 measurements and you would simply calculate the average, and you wouldn't report the maximum. And you would do that for each set of readings. But both contracting parties have to agree. The default is you would report the maximum value for each area.
Now, I can understand with the replica tape, you record a value or two. In your case, 10 readings for each location, that's a lot of data to manage. I mean, how do you handle that?
Yeah, it is a lot of readings, but the nice thing is, again, you have a data collection device that's connected to a probe here. Of course, it has the ability to record the measurements automatically in a memory, and you can assign a batch to that, and it can give you all kinds of statistical analysis like standard deviation, minimum, maximum values, number of readings you've taken, and the average, of course, as well.
Okay, so John, I understand in each location, Bill's taking 10 readings. How many tapes do you use in a given location?
So according to the ASTM standard, you should take at least 2 for each area.
2 in each area.
That's correct.
All right, now let's assume that I'm in that overlap. Do I have to now take 4 since I do 2 in the overlap area?
Effectively, yes, because you have to take the 2 readings for each and then average of those 2.
Oh, okay. So potentially 4 pieces of tape in a given spot.
That's correct.
So what are the advantages of using the replica tape?
So there's a few advantages. One, it becomes a permanent record. I mean, you have something you can actually, it's tangible, you can hold it, you can take this and actually attach it to your report so that it's it becomes part of the record. Also, I mentioned earlier about some of the interpretation between the digital gauges and the highs, the lows, which ones are erroneous readings and such. This sort of takes that away from it by using the overall average. And there's plenty of other things that we're, new technology that we're using with this tape that we can learn more about the surface profile, peak density, those sorts of things.
Okay. Now, Bill, John makes a compelling case for a permanent record. I can see attaching that to a report as long as you don't crush it in a book, being able to access it in the future. Do you have permanent records like that?
Yeah, I guess going back several years, one of the limitations to using a gauge with a cone shape or conical shaped point on the bottom is they were all analog. So you had to write down every reading you took, and then that would become your permanent record. Now, because these are digital, of course, we can dump all of our readings into memory, and we can upload that to a spreadsheet, we can download it to a printer, and we can even upload the data to a cloud-based server, so it's a very permanent record. And I argue in this case is we don't have to worry about preserving that compressible foam that may get crushed or may expand over time because of temperature limitations. We've got a paper permanent record of it.
Well, John made a comment that with his tape or the replica tape, you don't have to make the user doesn't have to make a lot of decisions. For example, is this reading an outlier or is it not? It seems to make a good point to me. What do you have to say to that?
Well, I guess when you're identifying outliers, it really isn't as difficult as it may sound because you're looking for obvious outliers. You're looking for a single data point that doesn't match the others. In fact, when I'm giving training classes on using this type of equipment, what I'll usually tell people is, go ahead, get your 10 readings, write them down, or put them into memory, and then scan through them. And if you see one or two that are not like any of the others, replace them. And it's much easier to identify outliers after you have a full data set versus trying to figure out what an outlier is as you're getting your measurements.
Okay. John, I see you have another gauge that looks sort of like the gauge Bill has here for the depth micrometer. It looks very similar. What is that all about?
Well, it uses the same body on top, but the probe on the different is called an RTR, which is the Replica Tape reader. So much to Bill's point of having a digital record of it, you can take the Testex tape and measure it using the RTR and actually take this tape and convert it to a digital record that could also be incorporated to a digital report or cloud-based server or print out the readings as well.
Interesting. Well, it sounds, Bill, to me that the Replica Tape with that reader almost like the best of both worlds.
Yeah, there's advantages and limitations to any of this equipment. You have an expendable there. The Replica Tape, currently it's running about 70 cents, maybe 75 cents for each piece, and that doesn't sound like a lot. But if you end up in the 1.5 to 2.5 mil overlap zone that John was talking about, you're going to be using 4 pieces of tape for every area that you check because duplicate measurements plus being in the overlap zone. So now for every area you're consuming about $3 worth of tape. Let's say you're going to check 10 areas across a prepared surface. You've gone through $30 worth of replica tape per area. With the digital micrometers, once you purchase the gauge, there is no expendable items at all. And in fact, you can increase the number of readings with the depth micrometer if need be, because ASTM says to take a minimum of 10 readings per area. But every time you want to double check your work with that, you're consuming another 70 or 75 cents. But there are limitations with these gauges. If for some reason the user drags the gauge, and I'll simulate that here, if they were to drag it across the surface versus picking it up and putting it down each time, you would dull the stylus, and so you're going to get false low readings because you've kind of rounded that tip. Now, the tips can be replaced. It's a pretty economical replacement to do that if it does become damaged. But it's important to pick the gauge up and put it down each time and not drag it. The other thing is, with proper use, you'll get it calibrated annually, and we can verify that it's working properly on the zero glass plate that comes with the gauge. It really can operate quite nicely for years. And the other thing that's important to remember is a lot of times inspectors need to hang on with one hand. So the advantage of this gauge is it's one-hand operation. You can hang on with the other hand to make sure you don't lose your balance. With the replica tape, pretty much have to use both hands in order to get the measurements.
You said a couple things that are of interest to me. One is, he said, if you drag the gauge across the surface, you could dull the tip. Earlier on, you said you verify the accuracy putting this gauge on plate glass. I won't know that tip is rounded or sharp on a plate glass. I don't think I will.
That's correct.
So how do I know when it's too rounded?
Yeah, what I would recommend in that case, it's a great question, I'd recommend looking at it under a magnification versus a new tip, and you'll be able to see the slight roundness to it.
Okay.
But to the unaided eye, you probably would not be able to determine that.
I was just thinking as you're talking, maybe we could even have a plate or something that has a given profile on it you could use as your control to periodically check or something like that.
Yes, the Felsko folks make a horseshoe-shaped shim, but again, it's going to be placed on the glass, so it's just determining is the gap there. I'm not sure that it's going to be able to detect whether the probe has been rounded or not.
Okay. Hey, you said another thing. You said calibrate and verify accuracy. Can you explain the difference between those two?
Sure. And those terms are used interchangeably all the time, and ASTM makes a clear-cut difference between the two terms. Calibration is performed by the gauge manufacturer, an accredited calibration laboratory, or an authorized service center, and typically that's an annual check of the device against a traceable standard to make sure that it's maintaining its accuracy, and a certificate of conformance is supplied along with a calibration due date sticker typically. So that's something that's done on an annual basis, and it's done by an authorized agency or the manufacturer, where verification of accuracy should be done prior to each use.
Okay.
And that's done by the person using the gauge. In this case, it's done on a glass plate, perhaps even with the horseshoe shim here.
So verification of accuracy is what you do in the field. Calibration is a lab or manufacturer or something.
Correct.
John, you had mentioned earlier something about peak density, I think you said. Can you explain a little bit what you were talking about?
Sure. So peak density is the measurement of peaks per square centimeter of an area. And what Replica Tape actually allows the user to do is measure peak density in the field using rugged field equipment. Typically, you're not able to measure peak density unless you have some very specialized lab equipment, and of course that's not practical in the field if you're measuring girder on a bridge or inside of a tank, something along those lines. So with the Testex tape and the special probe that you can, another probe that you can use, actually measures and can capture, like almost in a 3D image if you're using the proper equipment, the peak density. You can count it and actually render an image. Yes.
So right now we're measuring profile. In the future, who knows, we may be getting into peak density as well as an inspection criteria.
That's correct.
Interesting. All right, you both done a great job explaining how to use the instruments in a given location to take a single reading. But Bill, I guess I'll ask you, how many readings do I take in an entire tank or a bridge or what have you?
Yeah, that's a good point, and we were actually in trouble for a few years on that issue, because ASTM did a great job of telling us how many readings to take per area, but what they didn't tell us is how many areas to check on the job. So it was very much up to the individual project manager or inspector on the job, unless of course the specification gave you a specific frequency, which was rare. Folks probably assumed it's in ASTM. It's in the ASTM standard. So about 5 or 6 years ago, SSPC, Society for Protective Coatings, actually created, balloted, and approved a standard. It's called SSPC PA17, and it's a procedure for determining whether or not your profile measurements that you take actually conform to the specification requirements. And it can be surface profile requirements or surface roughness requirements, or like John was talking about, either peak density or peak count measurements. It addresses all of those things. But basically, that could be an entire podcast in itself. But basically, it references ASTM D4417 for how to take the measurements, and also how many measurements to take per area. But when it comes to how many areas, basically what they say is to check a minimum of 3 6-inch by 6-inch locations per work shift or 12-hour period, whichever is shorter. And that's a minimum now. And so if you think about it, there's a lot of factors that it can affect surface profile, but the biggest is the size of the abrasive. So as long as the contractor is using the same size abrasive throughout the work shift, things shouldn't change a whole lot. So these number of areas that they recommend or specify as the standard is probably sufficient, although again, you can take more. And the average of all those areas has to meet specification. And if it doesn't, if you have a bad area, then the PA17 standard gives us a procedure for determining the magnitude of that non-conforming area.
Okay. All right, we've been talking blast cleaning, and Bill, you mentioned blast cleaning. John, let me ask you, a lot of times we see specs for power tool cleaning to bare metal or commercial grade power tool cleaning. Can we use and it's usually a 1 mil minimum profile with the power tools. Can we use the replica tape on that?
So according to the standards, no, because SSPC, SP11, and 15, as well as the ASTM standard, both reference using method B, which is what Bill was showing with the digital depth micrometer. The NACE standard, SP0287, does not even address the use of replica tape for power tool.
I know they've been doing some research. Is there a chance that might be allowed in the future build? You know?
Yeah, John's correct. Currently, Method B says that the only procedure, I'm sorry, the STM standard says that Method B is the only procedure you can use on power tool clean steel, and of course that's the depth micrometer. But there's been some recent research that was published at the SSPC conference in 2018 that suggests that replica tape may be able to be used on power tool clean steel, but the standard doesn't recognize that yet. The ASTM standard as well as the SP11 and SP15 power tool cleaning standards from SSPC both still reference only the depth micrometer.
Okay. All right, my last question. You guys have done a great job theoretically or tell us how to use the instruments. Now here's a real world question. Let's assume we're on a job site and the specification says the profile should be 2 to 4 mils. And the contractor, John, comes with replica tape. Bill, the owner, comes with the depth micrometer.
Mm-hmm.
John, I'll start with you. Do you expect the readings to be similar between those two measurement techniques?
I would say they're similar, but there's a good chance that they would be different just because of the different methods being used.
Bill, do you agree that they'd be different?
Yeah, I would suspect they would be different. What we have to remember is we're measuring surface profile using two different methods. The replica tape is taking an image over about a 3/8 inch diameter circle, the test area that John described earlier, and kind of averaging that, where the digital depth micrometer is taking pinpoint measurements. You know, the stylus is going down into a valley, and the base of the instrument, which is probably, I'm estimating, about 3/4 inch diameter, is sitting on, you know, arguably hundreds of peaks. And so you're getting a pinpoint measurement versus an average measurement. The values are going to likely be different.
John, do you think we got this dispute? Which one would be correct? Who would?
Well, it's difficult. You can't say one's more correct than the other. It would have to go back to which method is required by the specification or the standard. I mean, when you, again, comparing apples and oranges, between the two, I guess in my experience, the digital depth micrometer has been a lower profile compared to the surface, the Testex tape, the replica tape. But I'd say you have to be using the same method, the same type of equipment to measure it. Otherwise, you can't say one's right over the other.
So you're saying both could be right, both could be wrong.
Potentially.
Interesting. Bill, any way we can overcome that? Or?
Well, I mean, there's a couple of ways. First of all, really, it should be addressed by the specification. You know, good, thorough specifications are going to say measure in accordance with ASTM D4417 method A, method B, or method C, whichever the specification writer wants, so that all parties on the job are using the same method. Let's say that's missed, though, and it's just references the ASTM standard because the specification writer's unaware that there's 3 different methods embodied in that single standard. It's something to bring up during the pre-construction conference. Get everybody on the same page. Because when there are differences and one set of values is within specification and one set of values is out, then we begin the arguing process.
Interesting. Wow, a lot of information. Do either of you have any closing comments or remarks?
Nothing comes to mind for me, no.
Yeah, I guess the key is that recognizing you can get different measurements with different devices. For years, the depth micrometers were not very popular because of the analog scale and very, very difficult to use. But now that they've become digitized and the price of the replica tape is going up, now we've got an overlap zone we have to deal with in some cases between 1.5 and 2.5 mils, where we have to start figuring out if we have to take additional measurements. It wouldn't surprise me if more people are going to start, shifting towards the digital method. But it's good to have agreement up front as to which is going to be used on a single job.
Good, thank you. And I'm going to go ahead and summarize sort of what I heard during this podcast. Because a few things, starting from the beginning, we're not calibrating the gauge in the field. We're verifying the accuracy So the use of the word calibration for what the inspector or person does when they're using it is really the wrong term. It's verifying accuracy. The depth micrometer is good for both blast clean steel and power tool clean steel. But right now, the way the standards are written, the replica tape can only be used on the blast clean steel, although that might be changing. The depth micrometer, we're going to take 10 readings per location throughout the outliers, and you can either average them together or use the highest reading. The ASTM standard prefers the highest of those 10 to be the profile, but upon mutual agreement with the parties, you can average those 10 together. You can store that data permanently for statistical analysis, one-hand operation, which is nice if you're holding on to a ladder or something, and you can't drag the probe across the surface though to get a reading, which I've seen people use that and they have a tendency to do that, to watch that dial fluctuate or watch the digital fluctuate, but you really can't do that and should not do that. And it gives you readings in tenths of a mil. For the replica tape, there are spring-loaded micrometers. You can't use the screw-type micrometer. It's got to be these light spring-loaded micrometers. There are a couple different types available. No matter what you do, you have to make sure you take into account that 2 mils of mylar, so you're not reading it as if it is profile. It has to be removed from that reading by any number of ways. There are 2 tapes used per test location, but if you're in that overlap between the course and the extra course, you'll have to use 2 tapes, one of each, to get one of those 2 readings. So conceivably, in each location, you may have 4 tapes being used. So at a minimum, it's 2 to 4. It also serves as a permanent record. It can be expensive, 70 or 75 cents per piece. It does take 2 hands to use, and there may be potential error if you don't rub it enough or you pick up dirt or dust or something that you read as profile. The replica tape reader for the tape is a digital reading of the profile that can be stored electronically, which is nice, and it can also determine peak density. You will get differences in readings in the same spot. The depth micrometer looks at individual valleys that it's reading, whereas the Testex tape uses a larger area to kind of average those peaks and valleys together. So there will be differences. The way to get around it right now is to specify the specific method that is used, method A, B, or C in the specification. In terms of the frequency of measurements, SSP CPA 17 will give you those frequency, and basically it's 3 6-inch by 6-inch locations per work done that shift or 12 hours, whichever is less. So that's it for this podcast. Please log on to KTA-University.com for other podcasts and other technical articles related to cleaning and painting. Thank you.